What type of acceleration does an object moving with constant speed in a circular path experience? A. Free fall, B. Constant acceleration, C. Linear acceleration, or D. Centripetal acceleration. So let's go through all of our answer choices. So A states that our object is in free fall. So we know if we have some object above our level ground, say it's a red ball, we're going to drop it. We know that its acceleration due to gravity, g, directed downward, and this is not going to create a circular motion. We know the path that this ball is going to fall. It's very intuitive. We know offhand that the ball is just going to fall straight down. This is not going to result in the ball following any circular path floating in the air, because there's nothing to keep it in the air. It's only the force due to gravity acting on it, so our object would just fall straight to the ground. So, answer choice A doesn't make any sense. B states that we have a constant acceleration. Well, don't get tricked by this. Technically, our acceleration is constant, but it's not the correct type that we're looking for. The constant acceleration fits for a whole large range of problems. So, for example, we have some object moving to the right with a constant acceleration. We know that what path it's going to follow. If we initially had a velocity of v0, our initial position was 0, we would know that our distance that it is from our starting point is given by 1/2 at squared. So if we're given a is constant, we know t, we can find how far we wind up away from our object each and every time. So here's t equals 1, t equals 2, then t equals 3. So here, this is also comparable to a constant acceleration. Now, C says linear acceleration. Well, this is also similar to our discussion here. We're accelerating in one direction, so in the direction that's linear, so a line. So we're just accelerating to the right. Now, answer choice D says centripetal acceleration. Well, we know centripetal acceleration is the acceleration that you experience as you're moving along a circle. So when our ball is at the top of the circle here, we know that we have centripetal acceleration, a centripetal, whichever way you want to denote it here, pointing toward the center no matter where along the circle you are. It's always directed toward the center. Now, with that being said, we can see that the centripetal acceleration is inherent only to a circular motion. That's the only time that you're really going to have a centripetal acceleration is when you're following some circular trajectory, some circular path. So our answer here is D. Just make sure you don't get confused with answer choice B. Because technically, yes, you are moving with the constant acceleration as you're going around the circular path, but they want to know a specific type of acceleration. So that would be answer choice D, centripetal acceleration.